Dear students, another exception in ionization enthalpy is that if you take nitrogen and oxygen in the second periods itself, nitrogen atomic number is 7, oxygen atomic number is 8. If you write electronic configuration of nitrogen, 1s2, 2s2, 2px1, 2py1, 2pz1. So that is 7 electrons. Oxygen, if we write 1s2, 2s2, 2px2, 2py1, 2pz1. So 8 electrons. So here the first ionization energy of oxygen is less than the first ionization energy of nitrogen. This is because in the case of nitrogen, 3 electrons in the 2p level are present in 2px1, 2py1, 2pz1. They are half-filled. They are exactly half-filled. 2p orbital is exactly half-filled in the case of nitrogen. We know very well the maximum number of electrons that can accommodate in p orbital is 6. But here in 2p orbital we have exactly half of 6. So that is 3 electrons. So 2px1, 2py1, 2pz1 exactly half-filled. They have maximum stability, completely filled, and exactly half-filled orbitals have extra maximum stability, so that removal of electrons becomes difficult from the stable orbitals. And also because of presence of one electron, singly occupied electron, one electron, so electron repulsion is minimum. Electron repulsion is a minimum. So size of the nitrogen atom decreases. So energy required to remove the electron from the smaller sized atom is more. In the case of oxygen atom, one of the 2p level is completely filled, that is 2px2. So because of presence of completely filled, that means paired electron repulsion is more in 2px level. Greater the electron repulsion, so then size of the atom increases, so that easier to remove the electron from oxygen atom. So that means first ionization energy required to remove the electron from oxygen atom is less than the first ionization energy required to remove the electron from nitrogen atom. And the next periodic trend in physical properties, 412, electron gain enthalpy, it is also called as electron affinity. Electron gain enthalpy is nothing but amount of energy released when an electron is added to the neutral gaseous atom in the ground state. It is opposite to the ionization enthalpy. Ionization enthalpy energy is required, but in the case of electron gain enthalpy, energy is released when an electron is added. When an electron is added to the neutral gaseous atom in the ground state to become a negative ion. Electron add ಮಾಡಿದ್ರೆ so ion ಏನಾಗುತ್ತೆ ನೆಗೆಟಿವ್ ಆಗಿರುತ್ತೆ. So that is when an electron is added to the atom, so the ion becomes negative, energy is released. Suppose if I take X is a gaseous or more. Release, negative indicates that energy is liberated. So electron gain enthalpy is nothing but the amount of energy released when an electron is added to the neutral gaseous atom to become a negative ion. It is also defined as the enthalpy change whenever electron is added to the neutral gaseous atom in the ground state to become a negative ion. Generally, when the electron is added to the atom, so the ion becomes negative and the energy is released exothermic. And once again, in the periodic table, if we take periods, that is in the periods, the electron gain enthalpy becomes more negative. When we move from left hand side to the right hand side of the periods, the electron gain enthalpy of the elements becomes more negative. This is due to the smaller size atomic radius, high ionization enthalpy, high effective nuclear charge, and high non-metallic character. Left hand side ಇಂದ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಕಡೆ ಎಲ್ಲ ಹೋದಾಗೆಲ್ಲನೂ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ ಬಿಕಮ್ಸ್ ಮೋರ್ ನೆಗೆಟಿವ್. ಯಾಕೆಂತಂದರೆ ಇನ್ ದ ಪೀರಿಯಡ್ಸ್ non-metallic character increases, atomic size decreases, nuclear charge increases, and ionization energy increases. So that they have a ability, the elements in periods have a ability to gain the electrons and to become negative ions. So that energy released is more. So that is electron gain enthalpy becomes more negative in periods. Electron gain enthalpy becomes more negative in periods. Electron gain enthalpy becomes more negative because of increase in the nuclear charge. So that means in the periods the added electrons goes to the same valence shell, so that those electrons are attracted more towards the nucleus. Effective nuclear charge is more, so they have a tendency to attract or to gain the electron. So that electron gain enthalpy becomes more negative because of increase in nuclear charge. And down the group of periodic table, electron gain enthalpy becomes less negative. Down the group, electron gain enthalpy becomes less negative because of increase in the atomic size and because of decrease in the effective nuclear charge. Down the group, from the top to the bottom of the group, electron gain enthalpy becomes less negative because down the group atomic size increases. When the atomic size increases, effective nuclear charge decreases. The ability of gaining of electron decreases. Group top to bottom of the group ಏನಾಗುತ್ತೆ, atomic size ಜಾಸ್ತಿ ಆಗುತ್ತೆ, nuclear charge decrease ಆಗುತ್ತೆ, addition of electrons becomes difficult. So that gain enthalpy becomes less negative in the group. That is, down the group, electron gain enthalpy becomes less negative. Less negative due to increase in atomic size and decrease in nuclear charge. So it is down the group, electron gain enthalpy becomes less negative because atomic size increases. The added electron goes to the different shells, number of shells increases, effective nuclear charge decreases. So that it is not easy to add the electron to the larger atoms. Smaller the size, easier to the add electrons. So electron gain enthalpy will be more. That is in the case of periods. Larger the size, it is very difficult to add the electron to the larger sized atoms.